Start recording. Oh, I've started recording, even though I was talking about how I needed to start recording. Exciting. So we're talking about shoveling snow here, and specifically you wanted parts C and D. Just real quick, part A, just for fun, how much snow accumulates on the driveway by 6? Well, that's just the integral of the amount that accumulates from 0 to 6. So it'd be the integral of f of t from 0 to 6. And the rate of change of the volume of the snow on the driveway at 8 a.m. would just be the value of f of 8 minus the value of g of 8. So that should be pretty quick and easy to get through A and B, I would hope. And then part C is where it starts to get a bit more complicated. So part C, they want you to write a piecewise defined function for 0 to 9. That's going to give you the total amount of snow that has accumulated. Right? Oh, no, sorry. The total amount that she has removed, not the total amount that's accumulated. I should probably read the question correctly. So the first thing we want to do when we think about this is think about what does h of 0 need to be? The initial amount needs to be 0. She has removed no snow. And so we then have an amount that she removes per hour from t equals 0 to t equals 6. So we're going to say all the way up till, we're going to say from 0 to 6, the amount that has been removed ought to be the amount that was already removed, which is 0, plus the integral of the rate at which she is removing it. Well, the integral of 0 dx from 0 to t, right? So she's removing 0 cubic feet per hour from t equals 0 to some time that is between 0 and 6, which still ends up just being 0. Huh? Everybody good with that so far? Okay. So then we would say from 6 to 7, the amount that has been removed is the amount that was removed up till t equals 6, which was 0, plus the integral from 6 to some t value between 6 and 7 of this rate, 120, we'll call it dx. So the integral of 125 dx is just 125 x, and we'll evaluate that from t to 6. So that ought to be 125 times t minus 6 from 6 to 7. So if you plug any value in between 6 and 7, that tells you how much snow has been removed. Everybody okay with that so far? Oh, I've moved my circle. There we go. Yeah, everybody good there with the first couple?
Yes.
All right, cool. Try to move this up. There we go. Now I got more room to write. Okay. And then from 7 to 9, the amount that has been removed is the amount that was removed in the first 7 hours. So h of 7 would just be 125. And then now plus an integral from 7 to t of the rate at which it's being removed, and that's 108. And so that ought to be 125 plus 108 times t minus the 7 for your definite integral there. And so you'd write this out as a piecewise defined function. From 0 to 6, h is equal to 0. From 6 to 7, h is equal to 125 times t minus 6. And from 7 to 9, h is equal to 125 plus 180 times t minus 7. Does that make sense to everyone?
Could you also leave it with the integral in the piecewise, or no? Because like I looked up the answer and I think it had the integral still in the piecewise.
It does not actually have the integral, and no, you need to have the integrals out of it. They don't want the integrals to be involved in it anymore. It's like if you're looking at the scoring guide, if you look below, like they show all the work that we just sort of showed here. I think I showed a little bit less than what they wrote out. But then below, when they actually wrote out the function, they said h of t is equal to 0 and then equal to 125 times t minus 6, and then 125 plus 180 times t minus 7 for for the different intervals. And they specified what those different intervals were, but they didn't have any integrals in it in their final answer.
Okay, thank you.
And then each piece of that 0, 125 t minus 6, and 125 plus 108 times t minus 7, each of those pieces is worth 1 point. And Dylan, I'm not sure. I think I would give you the points for it, but it only specifies if you have to have the correct final answer. It doesn't specify showing the work. So if you didn't show the work, I think you're probably okay on that one. Probably. And try to show some work in general. All right, and then part D. And Dylan, also, just the more work you show, the better chance you have of them giving you more of the points. Because a lot of times they associate points with specific work, even though they don't say that in the problem. So the more work you show, the better. I should probably read what part D says. Part D, how many cubic feet of snow are on the driveway at 9 a.m.? So the amount of snow that should be there should be the amount that has fallen minus the amount that has been removed, which would be h of 9. So we want to find this is part D, the integral from 0 to 9 of f of t dt. And then we are going to subtract from that the amount that Janet has, through back-breaking labor, removed in those 3 hours. And that value comes out to be about 26.334. Everybody good there? Any questions on the snow problem? Or other questions?
Wait, I have a question. Could you explain the fundamental theorem of calculus again?
Sure. The fundamental theorem of calculus, part 1, says that the derivative of an integral from a constant to x of any function just equals that function evaluated at x. That's the first part of the fundamental theorem of calculus. So suppose we had though something like a constant x squared of a function. That should equal f of x squared times the derivative of that function. That's all it is, that the derivative of the integral from a constant to a variable is just the original function. The derivative of a constant, or the derivative of the integral of a function from a constant to a function is just the original function evaluated at this other function times the derivative of that function. Does that make sense?
Right, but I just had one more question. Like sometimes I see them doing like f of like the x minus f of c. Like, what's that about? Because I got confused when I was reading about that.
Well, so what we sometimes do is we say let capital F be an anti-derivative of f of t. And so then technically you do this first, right? You get capital F of x squared minus capital F of c. That's the second part of the fundamental theorem of calculus, right? Evaluating the integral at the upper limit minus the integral at the lower limit. And then we'd be taking the derivative of that, because we have a derivative out in front still. So the derivative of capital F of x squared, that's the chain rule part. That's why we get a 2x little f of x squared. And then this is f of a constant, and f of a constant is a constant, and the derivative of a constant is 0. Is that what you mean? That they were like writing it like that?
Sorta. I was more talking about like, where's the question? Oh yeah, for like the constant question for C, because that's also the fundamental theorem of calculus, right? But why is it W2 minus W of 1?
That's perfect, because somebody was asking about part D of that one. Okay, so you're saying, why is it W of 2 minus W of 1? I'm not sure what you're asking about it there, though. You're not using the fundamental theorem of calculus there. You're just using an integral.
Right. So you take like the integral from 1 to 2 of the derivative of WT, right?
Right. I mean, W of 2 minus W of 1 is the integral from 1 to 2 of W prime. So if you're looking for W2 minus W of 1, just find the integral from 1 to 2 of this function. That's got nothing to do with the fundamental theorem of calculus, because there's no taking the derivative of the integral. We're not taking the derivative of anything here. We're just integrating it to get this value.
Okay, I get it. So integrals of derivatives are not the same thing as derivatives of integrals, which is what the fundamental theorem is about.
Yeah, I mean, it is the same. I mean, the integral of the derivative of W is W evaluated in each of these things. I mean, it's still just, if you think about your original function as being W, yeah, well, we've taken the integral of the derivative of it, which gives us W values at these upper and lower limits. But these are both constants this time, so you got to plug them both in. We're not going back and taking the derivative of the integral, which is what makes the constants go away. When you already have a derivative and you integrate it, you have to figure out what the number itself is. Does that make sense?
Yes, it does. Thank you.
Sure. All right. And then the question, I think, was also for D of this problem. I believe it was this problem. Is that right? Okay. So just for a little bit of context, they said that W is the total wait time for all the people who enter the auditorium before time T. And so if we want to know how long a person, on average, how long any person randomly waits in the auditorium for this concert, and we have to consider all people who enter the auditorium after the doors open, it should be the part D should be the total wait time of all from 0 to 2 divided by the total number of people, which is the answer from part A. So the total wait time of all the people from 0 to 2 ought to be the integral of W prime from 0 to 2. And then we ought to divide that by the answer from part A, which is how many people are in the auditorium when the concert begins. Well, this is the rate, so that ought to be the integral from 0 to 2 of R of T, which you would have already found at the beginning of the problem. I believe that number, that I did this last grade, I think that was 980. So whatever the integral from 0 to 2 of this is, divided by 980. And that gives you some number, I don't know. find the scoring guide for this one to know exactly what it was. But see here. I don't know. I don't offhand know what the value of that is. Does that make sense? Okay. And then can I do part D for the cylindrical can and D for the water? Okay. Let's see. This is got water in it, but I don't think that's the one you're talking about. That's a tree. Trees need water to be alive, but that's probably not what you're talking about. This one? Is this the cylindrical? No, that's not a cylindrical can. Tank of water. Let's keep going up. This one. Okay. Yeah. The 12,000 liter tank of water. Does that look right? Okay. So and you just wanted part D for this. So we want to write an equation involving an integral to find the time when the amount of water in the tank is 9,000 liters. So in order to figure that out, we need to have an equation with an integral that represents the amount of water in the tank. And so it starts out filled to capacity, so its initial amount is 12,000 and water is draining out of it, so minus an integral from, and we'll just say 0 to a of r of t, because we're trying to find out when this equals 9,000. And so 12,000 where it starts, this is how much is leaked out between t equals 0 and t equals a, and we want that final amount to equal 9,000. So this is what we would do. And that's good enough. That would get you all the points for that answer, I'm sure. Does that make sense? Okay, and then something about a cylindrical can. That must be this one. Okay. Yes. Stormville. Exciting. Stormville is my child's favorite. Okay, so Stormville. And we're looking here at a 60-day period. We have a rain on Monsoon Mountain and accumulates in a can identical to the one in Stormville, which has got a radius of 10 millimeters. And the height of the water in this can is measured by M. And let's see, D is M prime minus S prime. And S prime was the rate at which the height of the water in Stormville's can is rising. We want to apply the intermediate value theorem to the function d on 0 to 60 to justify that there exists a time in which the heights are changing at the same rate. Okay, fun. So if the rates are changing, or if the heights of the water are changing at the same rate, that would tell us that M prime, which is the rate of change of the height of Stormville, needs to equal S prime, right? So we want to know when does M prime, we want to prove that M prime equals S prime at some value. And since D is M prime minus S prime, we'd be looking for M prime minus S prime equals 0. So we are looking for when does D of t equal 0. And so if we can prove that d of t equals 0 at some point between 0 and 60, then we can say that this must be true. And it says to use the intermediate value theorem to do that, which means that if we want the value of d to equal 0, we just need to show that at some point d is greater than 0, and at some other point d is less than 0 on the interval from 0 to 60. And we'd also have to say, since we're using the intermediate value theorem, that d is a continuous function. And we know that s prime is continuous, and if you integrate a continuous function, you get a continuous function. And m is a continuous function, and you take the derivative of a continuous function, you get a continuous function. So d is a continuous function because m and s are both continuous. And so all we've got to do then is see if we can find a place where d is greater than 0 and find a place where d is less than 0. And generally, when you put problems like this on the AP test, you just want to check the endpoints, and it'll should show that at one of the endpoints it's positive and the other endpoint it's negative. So we will look at d of 0, and d of 0 is m prime of 0 minus s prime of 0. And we should be able to figure out what that is pretty easily, right? Probably here. M prime is going to have a bunch of t's in it, except this last one will be a 330. So we'll have 330 over 400 for m prime at 0. And then s prime is already this. At 0, that's 1.5. So 330 over 400 minus 1.5 is less than 0. And then you'd look at m prime of 60 minus s prime of 60. And that value, whatever you get out of here is going to be between, -1 and 1. So this is a very small value for s prime of 60. But m prime of 60 is going to be pretty darn big. It's 9 times 60 squared minus 60. That's still going to be 9 plus 330. So this is going to be a larger value. And so m prime of 60 minus s prime of 60 is going to come out to be something that is positive. And you could get the exact value just by plugging it in if you wanted to. And then you'd say by the intermediate value theorem, since d changes signs, it's negative at 0 and it's positive at 60. Therefore, there must be a place where d of t equals 0 on that interval. And therefore, there must have been a place where the m prime was equal to s prime. Does that make sense or not? A little bit complicated there, but yeah, cool. Anybody else? Any other questions?
I'm sorry, I'm quite confused on the rock concert problem. For
Okay.
C, like I know you already talked about it, but I'm still confused about why you would want to take the integral of the derivative to find w of 2 minus w of 1.
Well, because that's, if we're looking for w of 2 minus w of 1, that can be written out just like this integral. I mean, if you integrate w prime, you get w, right?
Yes.
Yeah, so, and if we put a definite integral on here as the definite integral from 1 to 2, then we have to evaluate the integral of w prime at 2 and the integral of it at 1 and find the difference, which is exactly what we want, because we want the difference between w at 2 and w at 1. So the integral of w prime gives you w, and then the fact that it's a definite integral says evaluated at 2, evaluated at 1, and subtract.
I see. Thank you.
No problem. Any other questions?
If you're finding an average value of a function, is there any requirements? Like, does it have to be differentiable on the whole function or continuous?
It doesn't need to be continuous or differentiable on the entire interval. If it's not, then you just have, like, if it's not continuous, you have to separate it into like 2 different pieces, like up to the discontinuity as one piece, and then after the discontinuity as another piece. And if it's not differentiable, so like if you have something like this, that's fine. To do the integral part of it, you just do each piece separately. Wherever the, if it's like, if it's geometric, like if I gave you a graph or something, you just find each piece separately to find the value of the integral. Kind of like we did in some of those multiple choice definite integral problems. Does that make sense?
Yep.
Okay. Any other questions? All right, sounds like it's time for a quiz then.